In this video, we will be discussing about sine rule, and this is going to be a very important result for you to apply, and even for Lamis theorem, it is going to be really useful. And Lamis theorem is actually derived based on this. So what is sine rule? It's so simple. Let us consider a triangle. Suppose you are considering a triangle. Let me use that. Let me construct a triangle. Suppose this is one side of the triangle. This is another side of the triangle. This is another side of the triangle. So we have constructed a triangle, and let us name the vertices of these triangles. Suppose this is vertex A, vertex B, vertex C. And now what we do, let us give the names for the angles. Suppose the angle CAB, let's say this angle is A. The angle at the vertex B, let us call it B. Angle at vertex C, let us call it C. Now two more things, the sides of the triangle. Basically in sine rule, we are going to connect the angle and the length of the side. That is what we are going to connect. And the angles, this is C, capital C. Let us consider this length as C. Let us consider this length of the triangle as, this is opposite to A, let us call it A. And let us consider this side triangle, this is opposite to B, let us call it B. Okay, so we are going to name them right now. So opposite to A is A, and opposite to C is C. C, A, and then this small b are all lengths. Capital A, capital B, capital C are not only the angles, we name them verticals also. Now we are going to consider two lines. We are going to draw a perpendicular line to the other side from the vertex. From C, let us draw a perpendicular line from here to this. It's a perpendicular line. Once you draw a perpendicular line, let us name this point also. Let us name this point P. Now consider a triangle ACP. This triangle, this is a right angle now, because we drew the line in such a way that these two are right angles. In such case, so what will happen? In this triangle ACP or ACP, A is this angle, this is opposite side. Let us give the length of this opposite side is A, and let us write right now what is sine A in the triangle ACP. So sine A is opposite side by hypotenuse side. Opposite side is H, hypotenuse side is B. So sine A is equal to H by B. At the same time, consider this triangle BCP. In this triangle BCP, what is sine B? Sine B is opposite side by hypotenuse side. So H by A. So sine B equal to H by A. From this cross multiply, H is equal to A sine B. Here H is equal to B sine A. Their right hand sides are equal, left hand sides must be equal. So B sine A equal to A sine B. So sine A by this A is equal to sine B by B. And what we are going to do is to get the complete picture, we are also going to draw a perpendicular to the other side. Let me choose a different color for this line, and from A to this side perpendicular, you draw one perpendicular, and this is right angle and this is also a right angle. So let us give, this is 90 degree, this is 90 degree. Since we named it P, let us name it P prime. This length was H, this length let us call it L. Now that you have got two right angles with this line, one is BCP prime, the other one is CAP prime. So now what we will do is, in this triangle BCP prime, what do we get? Sine B is opposite side by hypotenuse side, because in this triangle this is hypotenuse side, this is the adjacent side, this is the opposite side. Opposite side is L. So now what are we writing is sine of this angle B is opposite side L by hypotenuse side. This hypotenuse side, this one, this side BA is actually C. At the same time, in this triangle CAP prime, in this triangle CAP prime, what is this angle is C, right? C's opposite side is L. So sine C equal to opposite side L by hypotenuse side, this side. So for this triangle, this is hypotenuse side, so that is B. Then L is equal to C sine B and L is equal to B sine C. Since right angle side and left hand sides are equal, then C sine B equal to B sine C. So sine B by B equal to sine C by C. Now in this, look at these two equations. These two are equal, right? So sin A by A is equal to sin B by B. Sin B by B is actually equal to sin C by C. So let us write them all together. We'll get that relation. What is that? Sin A by A. This is length. So sin B by B, which is equal to sin C by C, where A, B and C are the angles. A, B and C, these small a, B and C are lengths. So this is what sine rule is. So what is that sine rule? So sin A by A equal to sin B by B equal to sin C by C. And once you are thorough with this, we are going to apply this in Lami's theorem, so that we will, for a kind of three forces acting such that they form a triangle. In such case, we will be applying this to arrive at Lami's theorem.